All right, welcome to Coach Taylor's class notes, and today we're going to use what we've learned about parallel lines and transversals, and we're going to turn them into proofs. So the first and the most important thing for us to understand is that we have two different types of proofs, and we have two different types of theorems and postulates that we're going to use. So we're going to talk about this first column first. So these postulates and theorems are corresponding statements. So we have if a transversal intersects two parallel lines, that's our hypothesis, then our conclusion is that the corresponding angles are congruent. So this is written in a P then Q format. And so these postulates and theorems we're going to use to prove, I'm saying this wrong. We're going to use when we know the lines are parallel. And so when we know the lines are parallel, then we know that our corresponding angles are congruent. When we know, that's a really bad congruent sign. When we know that the lines are parallel, then we know that alternate interior angles are congruent. When we know that the lines are parallel, we know the alternate exterior angles are congruent. When we know they're parallel, we know that the consecutive interior angles are supplementary, so they equal 180 degrees. When our consecutive exterior angles, when we know our lines are parallel, we know the consecutive exterior angles are supplementary, which means they equal 180. And so now we're going to talk about the converse of these theorems. So the converse of these theorems is when we need to prove the lines are parallel. So if we look at our corresponding angles theorem and then look at our corresponding angles postulate, or our converse of our corresponding angles postulate, if we go back to Unit 1, we remember that the converse means we switch our hypothesis and our conclusion. So this one is going to be if two lines and a transversal form corresponding angles that are congruent, then we know the lines are parallel. So again, this statement is written as Q then P. So converse just means we switch the statements. So we have to prove the opposite to know. So in this case, when we know that we have corresponding angles and they are congruent, then we also know that the lines are parallel. When we know that we have alternate interior angles and they are congruent, then we know our lines are parallel. If we know that alternate exterior angles are congruent, then we know the two lines are parallel. If we know that our consecutive interior angles are supplementary, then we know the lines are parallel. If they have a consecutive exterior angles that are supplementary, again, we know that they are parallel. So we use the converse to prove that lines are parallel. We use the original postulates and theorems when we know that they are already parallel and are trying to prove the angle relationships. So in this first bit of our notes, we are trying to prove that the lines are parallel. So if we're trying to prove that the lines are parallel, then we want to use the converse. So when we are doing this, first and foremost, we have to figure out which angles we know, what our transversal is, and what lines we're looking at for parallel. So when I created this notes, it cut off our A and our B, but we have lines A and B are going left to right. They are horizontal. Lines C and D are going up and down. So let's look at these first two angles that we are given. So we have angle 2 and angle 4. So I find angle 2, I find angle 4. Angle 2 and angle 4 have line A in common. So if they have line A in common, then the lines that we are looking to prove to be parallel are going to be C and D. Because remember, whatever line the two angles are touching is going to be our transversal, and then whatever two lines the transversal cross is going to be parallel. So 2 and 4, we know are corresponding angles. And because they are corresponding angles, we're going to use the converse of corresponding angles. And again, we said since 2 and 4 are both on line A, that makes line C parallel to line D. All right. I'm going to have to rewrite this every time, or else it's going to become really hard to follow and understand. So now we're looking at angle 5 and angle 10. So I'm looking at 5, I'm looking at 10. The line that 5 and 10 are both on is line C. So if they're both on line C, that means that we are looking at line A and we're looking at line B to be parallel. So again, we know that 5 and 10 are congruent. Because we know they're congruent, we're going to use the converse of alternate interior angles, and I'm going to abbreviate it because I've got almost no space to write. And again, we said that since those two angles are on line C, C is our transversal, that means that A is parallel to B. Again, I'm going to erase it or else we're all going to get really confused very quickly. So now we are looking at angles 1 and angle 13. So I have 1 right here and I have 13 right there. 1 and 13 both share line C. And so the two lines that cross our transversal are going to be A and B. So I know that A is going to be parallel to B. And the reason that I know A is going to be parallel to B is because of the converse of our consecutive exterior angle theorem. Because 1 and 13, they add up to 180. They are on the outside of the two parallel lines, and so we know that they are alternate exterior. All right, now we're looking at 1 and 14. So I've got angle 1 right here. I have angle 14 right there. So they are both on the transversal C. And since they are both on transversal C, that is going to make A and B parallel lines. So again, A is parallel to B. And the reason I know that it's parallel is because it's the converse of alternate exterior angles. All right, angles 14 and 15 equal 180. So we have 14 right here and we have 15 right here. So that tells me that my transversal is going to be line B. So my parallel lines are going to be C and D. So we said C is going to be parallel to D. And they are alternate, or not alternate, they are consecutive. So it's the converse of consecutive interior angles. All right, so now let's look at 11 and 16. So I have 11 right here, and I have 16 right here. And 11 and 16 are on line D. But what I notice very quickly about 11 and 16 is they are not alternate interior, they are not alternate exterior, and they are not corresponding. The relationship they have is vertical angles. And so the thing about vertical angles is they are not one of our postulates or theorems from our previous page. So vertical angles can never be used to prove that lines are parallel. So they can prove no lines or none are parallel, and so that means we have no converse. And so yes, we know that they are congruent angles, but those two congruent angles do not prove that lines are parallel. And that's the thing we're looking for, is we're looking to prove that lines are parallel. Now let's look at 4 and 15. So I have angle 4 right there. I have angle 15. They are on line D, so D would be my transversal, which would make A and B my parallel lines. So A is parallel to B, and I know that 4 and 5 are congruent, and I know that the angle relationship that 4 and 5 have are alternate. So we're going to have to use the converse because, again, we are proving the opposite. V-E-R-S-E. So the converse of alternate exterior angles. All right, so now let's go into more full-fledged and long-term proofs. So in this problem, they tell me that 4 and 7 are supplementary. So I'm just going to go ahead and circle 4 and 7 are supplementary. And it wants me to prove that J is parallel to K. So that's the thing I'm looking for at the end. So I'm going to go ahead and write down my given. Angle 4 and angle 7 are supplementary. So that is my given. And so now let's figure out what else I know. So looking at angle 4 and looking at angle 7, they are not consecutive exterior. They are not consecutive interior. So it really doesn't help me a whole lot. I can't go straight into a converse. So we're going to have to do some thinking about these two angles. So one thing that I know automatically is I know that angle 7 and angle 5 are congruent because they are vertical angles. So angle 5 and angle 7 are, let me rewrite this. So the measure of angle 5 is congruent to the measure of angle 7. And the reason I know that is they are vertical angles. So now let's go back and let's keep looking at this. Now 4 and 5 are supplementary, correct? Yes, because I could replace 7 with 5, but I need to do a few more things before I can get there. So again, I know that 4 and 7 are supplementary, but I haven't stated the measurement of 4 and 7. So I'm going to have to go that angle 4, the measure of angle 4, plus the measure of angle 7 equals 180 degrees. And I know that because of my definition of supplementary. Once I have proven that 4 plus 7 equals 180, now I can substitute the measure of angle 4 plus the measure of angle 5 equals 180 degrees. And so once I know that 4 and 5 are 180, again, we use substitution because I just simply replace 7 with 5. So now I need to go back to my definition of supplementary because I need to prove that angle 4 and angle 5 are supplementary. So once I've proven that 4 and 5 are supplementary, I can then prove that J is parallel to K. And I can do this because I know that angle 4 and angle 5 are consecutive. Actually, I've got to use the converse. So the converse of consecutive interior angles theorem. Now this one's a postulate. So again, once I know they're supplementary, I have to prove that supplementary equals 180. Once I know that they are that, and I know that 5 and 7 are congruent, then I can substitute 5 in for 7, and then I can again use my converse of consecutive angles postulate. So now let's look at one more here, or a couple more here. So I have been given angle 1 is congruent to angle 7. So angle 1, we're going to put measure because I need, no. So angle 1 is congruent to angle 7. That is my given. My goal is to prove that 4 is congruent to 8. So to get to 4 is congruent to 8, I first need to prove that L and M are parallel. So to prove that L and M are parallel, I'm going to need to use the converse. If I'm looking at 1 and 7, it's going to be the converse of alternate exterior angles theorem. And so that's going to tell me that L is parallel to M. Now that I know that L is parallel to M, I know that 4, angle 4, is congruent to angle 8 because of my corresponding angles theorem. So for the prove that L and M are parallel, I have to use the converse. But once I know that L and M are parallel, I can just use the regular theorem because I already know that the lines are parallel. So now let's look at our last example. So here, 5 and 8 are supplementary. So if I look at angle 5 and I look at angle 8, they are supplementary. So angle 5 and angle 8 are supplementary. That's my given. I need to prove that angle 3 is congruent to angle 6. So again, to prove that 3 is congruent to 6, I first have to prove that R and S are parallel lines. So R is parallel to S. So if I'm looking at 5 and 8 and I'm given that 5 and 8 are supplementary, I need to use the converse of 5 and 8 are consecutive exterior angles theorem. So once I know that R and S are parallel, I do know that angles 3 and angle 6 are congruent. And the reason that I know 3 and 6 are congruent is alternate exterior. Nope, not exterior. I always get those backward. I always write them backwards. I know them, but interior angles theorem. And so that's how we use proofs and the converse of proofs to prove that lines are parallel or to prove angle relationships.